So today I will be talking about multimodal automated fact-checking, a survey, which is a paper we recently published at EMNLP 2023, which is one of the main publishing venues for NLP research. As Anna already did an introduction, I'll skip these first slides and get right away to the work which I'm presenting today. So this is our work on multimodal automated fact-checking, which has been done together with great collaborators from the University of Cambridge and King's College London, and was done mostly during my time at Cambridge.
Don't think your screen is connected.
Oh, okay. Strange. You're not seeing the slides moving.
You need to share the screen, not the. Yeah.
Okay, let me just see. Okay, then I'll go over to this view. Okay, now it should work. Let's see. Okay, great. So in during the talk today, I will start with a brief introduction and on the background of multimodal automated fact-checking, as I know that this is an interdisciplinary setting and we're coming from very different backgrounds. And I'll continue with then talking about the survey, what the goal was and our methodology, and then talk about the pipeline for multimodal automated fact-checking we introduced, and conclude with the challenges and future directions which we see as an outcome of this work we did. So basically, we deal with multimodal misinformation on a day-to-day basis. So we find in our daily communication or media we are consuming misinformation, for example, such as this Twitter post containing text as well as an image. This is related to the COVID pandemic, where we're seeing a peak in misinformation related to the pandemic. But also misinformation consists and includes synthetically generated images. More recently, with the work we have seen going on in generative AI, for example, this image, which is completely fabricated, showing the arrest of the former US president. Also, a very popular example is, I think, approximately 5 to 6 years old already, where videos of the former President Obama were created, where the speech has been manipulated, whereas the video itself was correct, but the speech was manipulated and not the correct one anymore. If we look at the rise of misinformation and see how this term has been trending over the Google Search API over the last couple of years, we see that there was a peak, specifically in 2016, due to two major events. Maybe you can remember that it was the year of the Brexit referendum, at the same time the US presidential election. Also another peak in 2020, where we have seen a rise of misinformation or fake news, however you name it, related to health misinformation and the COVID pandemic. As I've already mentioned a few different terms about the topic I'm talking about, fake news, misinformation, I'll give a short overview of the terminology I'll be using in this work. So based on the EU Code of Practice on Disinformation, published in 2018, I'm following in on my work the definition of disinformation they introduced as information which is verifiably false or misleading on the one side, and on the other side has been created with the aim and intention to deceive the public. Whereas misinformation itself, different to disinformation, focuses more on the first aspect of this definition, namely on verifiably false or misleading information, but does not make any assumptions about the malicious motives behind the information being created. And as I'm looking into the problem of misinformation from a computer science perspective and with the aim of developing technologies to assist this problem, I will be concentrating on misinformation and not making any assumptions about motives behind creation of such information. A term very quickly, which is also used, fake news, was more becoming popular in 2016 with the presidential election. However, due to the wide usage of this term fake news related to misinformation on the one side, misinformation the way I just defined it, but also used for hate speech, abusive language, but also in general to classify media organizations as itself. And therefore, during this talk, I won't refer to fake news, but consistently stick to misinformation. In general, I haven't mentioned before, if there are any questions in between about understanding, feel free to interrupt me. Otherwise, we have time in the end for questions. So misinformation and multimodality. So why are we looking at multimodal misinformation? So misinformation can be conveyed through different type of modalities, through images, audio, text, video, to name a few of them. And multimodality has become specifically relevant due to a few characteristics of this kind of misinformation. First of all, it spreads faster. Previous research has shown us. It gets a higher user group engaged on social media networks. And very recently, a term which we are probably now already familiar, generative AI, or models which allow us to generate text, video, images synthetically very easily, make multimodal misinformation an upcoming and important problem to look into. Typical examples which I will be referring during the presentations are, for example, manipulated content, just such as this one, unmanipulated content, which is just combined in a misleading fashion. For example, here you can see the caption of this image states having a blast in France, whereas the image itself is showing seemingly the Eiffel Tower, but it actually was taken in the US. So while it is not manipulated, it is misinformation which is being communicated. Another example is unmanipulated videos, audios, which embed text in a misleading fashion, such as here a video or memes, which is a very popular example we are familiar with. And finally, this is an example from a recent publication of ours, is where a claim, a statement, is misleading itself, and an unmanipulated content, for example, here a chart, is used to undermine what is being said. Let me now get to fact-checking, as the problem we're looking into is related to fact-checking. Fact-checking is a crucial part of news reporting and has the aim of verifying the truthfulness of claims which can be written or spoken on the one side, or also content in form of an image or video being spread. This task is usually performed by trained professionals, journalists, or fact-checkers I will be referring to during my talk, who try to understand an information given, try to extract evidence, which can be through interviews, documents, etc., in order to verify the correctness of the misinformation and just justify it in a way that is understandable for the readers or for the wider audience. Such as here, you can see an example from the PolitiFact website where the given claim is verified and justified with the statement you can see on this slide. And finally, more recently, a huge amount of misinformation being created and spread, there has been called from the journalism community that they need automation and assistance in this process, which was initially done mostly in a manual fashion. Let me now get right away, if there are no questions at this point, to our survey and start with the goals and methodology of our work. So there is previous work on multimodal automated fact-checking. So there is previous work across different types of communities, such as in the computer vision community, which is the machine learning or AI community, which deals specifically with visual data, such as images or video, has been working on manipulation detection, for example. The NLP community, which is my background, which deals more with language data in a written form usually, has mostly been concentrating on verifying textual claims. And for example, the speech community has been working on manipulated speech synthesis and trying to detect it. So each community of these, which I mentioned, has its own terminology, has its own data sets, models, and approaches to address actually a very related and similar problem. And the aim of our survey is to bridge this gap and try to unify the terminology in a way that the work is accessible across these communities, introduce a general multi-step pipeline for multimodal fact-checking. So we have a lot of data sets and tasks across the community, across these communities, and we try to map it to one unified pipeline and discuss the data sets and technology used. And finally, as I've mentioned, we address challenges and future directions. So our methodology is here listed in different steps and can be broken down into two subparts. The first subpart consisting of defining the scope of the survey.
Somebody online is not muted.
Sorry. No words. Okay, so the first part consisted of defining the research scope on the one side and selecting pivotal, highly cited research work, as well as using an incremental approach to collect and screen related research papers, starting with these pivotal works. What we also did, we manually defined a set of keywords, which we used to search across scholarly search engines. So this is one part for collecting relevant research work for our survey. And the second part consists of screening and filtering based on the abstracts and introductions of these research papers, and then classifying them and mapping them across a few different dimensions, such as the modality, the task, which is the focus of this research work, the contribution the paper is making, and finally, what type of research paper it is. Exactly. Based on this methodology, we then defined a pipeline for multimodal automated fact-checking, which I will be now talking in the next couple of slides. So this process is inspired by how human fact-checkers approach the problem of fact-checking. The aim was to define a unified pipeline, as I've mentioned before, and the pipeline consists of 3 different stages, which I will be talking more about in the next minutes. So basically, the aim is, given certain kind of information, such as a text, an image, or a combination of video and text, for example, similarly to human fact-checkers, try to understand the claim, extract it from the given context, and specifically filter for these kind of information, which is factually verifiable on the one side, and is check-worthy on the other side, similar to how humans approach the problem to reduce it to these kind of misinformation, which are important for fact-checking. Then following with a second stage where evidence is retrieved, evidence related to the misinformation at hand in order to automatically verify it. And finally, similar to what human fact-checkers do, verify the correctness of the given misinformation on the one side, and on the other side, produce a justification in a way that it's understandable for humans. Because coming from a computer science background, what is often the issue what we're having, that a model can work maybe very well, but as long as it's not understandable for the humans who should use it or make use of it, it's important to also have this final step of justifying why the model is reasoning and classifying the misinformation as it is. For each of these stages, I discussed the task definitions across the different communities we're looking into, benchmark data sets, which we surveyed, and discuss very briefly only the modeling approaches for each of these stages due to the limitations of time we have. So as a starting point for a survey, we manually reviewed 9,300 claims, which we gathered through the Google Claim Review API, with the aim to see what different kind of modalities are persistent and occur in real-world fact-checking. And here you can see an overview where, despite text, we have seen that 20% of claims which we reviewed have images present in them, followed by video, and to a very small amount, just audio. So audio is, of course, a part of video as well, but only 0.5% of claims were including only audio without video at all. So this is also one of the motivations why we specifically concentrated on these 4 different modalities, which you can see here as an input to the pipeline. The first stage, as I've mentioned previously, is called claim detection and extraction. So the aim of this stage, as I've mentioned previously, is to have a kind of filter of the set of claims which should be reviewed by defining those claims which are factually verifiable. As an example, an opinion could be misleading, for example, but should such a statement be verified or not is a different kind of discussion. On the one side, on the other side, check-worthy claims. So check-worthy claims can be, for example, those claims which are relevant given the time frame, different to claims which have been, for example, previously reviewed already by someone else and are not interesting for an automated pipeline. So this is the first task, which has been mostly addressed in the NLP community previously. So this includes, but is not limited to, the task of claim detection extraction is not limited to collecting contextual information. So given a certain statement, collecting information surrounding the statement in order to understand what this claim or statement actually means. And then also includes, for example, a statement or a misleading statement embedded in the modality. A typical example would be a meme, for example. In order to verify the correctness of a meme, for our machine learning models, we would, as a first step, maybe need to extract the text out of these images in order to, for a follow-up step, do the verification process. We have reviewed different benchmarks for this task, and there are a few insights I would now like to share with you. So if you look at different benchmarks which deal with the task of claim detection extraction, we see that there is certain focus on specific kind of modalities. So there is a strong focus on misinformation consisting of image and text, as you can see in the first rows, and less an inclusion of other type of modalities such as image, audio, video, which is also understandable because this task has been mostly in the machine learning community being addressed from the NLP community, which has been looking mostly on text-related data, such as text and images, and created benchmarks based on that. Why we are looking specifically on benchmarks is the point that for developing automated approaches, no matter if using machine learning models or something else, it's important to have data sets as a first starting point. And previous work in the research communities has also shown us that the release of data sets for a certain type of problem has triggered a lot of research in this direction in the follow-up months and years. What we also see, if we look at claim detection extraction benchmarks, that they're mostly limited to an output of a few classes. So for example, in the first line, you can see that this benchmark, which is called VIBO, has an output of 2 different classes. So the benchmark only consists of the information if a given misinformation is correct or not correct. So it's a 2-class classification problem in this setting without any additional information, which might be interesting. If you look at the different sources which have been used to collect these kind of benchmarks, we see that very popular sources are social media platforms such as Twitter, Reddit, etc., but also closed platforms such as WhatsApp have been used a lot, particularly also triggered by work of Kim Garimela, which was a previous speaker at this seminar as well. If we now look into the modeling approaches for claim detection and extraction, we find that there is a strong usage of 2 different kind of approaches. On the one side, using OCR models, so a system which has the task of detecting and extracting text from a multimodal setting, such as an image or a video. Here on the right side, you can see TikTok videos, which have text embedded in them, and an OCR system or OCR model would extract this text out of the videos. Another popular approach for claim detection extraction is speech-to-text systems, for example, publicly available APIs, which have been used in previous research to extract the audio of potentially misinforming videos in order to do the automated fact-checking. And across different kind of communities, we have seen that researchers have trained neural models, specifically neural networks, to detect factual and check-worthy claims. So this is specifically how this approach has been addressed in the communities previously. Yeah, if you go now to the second stage, which is the evidence retrieval stage. So now after we have extracted the claims which are check-worthy and factual, in the next step, we try to extract evidence which can be used for the verification, similar to how human approaches problems. So journalism doesn't read a claim and depending on his background knowledge, he can or she can correctly verify if a misinformation is correct or not, but they need to retrieve evidence such that it is also understandable for a reader why a certain information is misleading or not. Here in evidence retrieval, we have seen that previous research has mostly taken 2 different approaches. On the one side, the claim itself was used as an evidence for the follow-up steps. This can be, for example, an image which is manipulated, then no additional evidence is retrieved, but just the context of the manipulated image is being used by a model to detect if certain areas of the image have been manipulated, for example. And the second approach, which I already mentioned, is to retrieve additional evidence. This can be from trustworthy text sources, but also from search APIs, but also extraction from databases, etc. If we look at the benchmarks, and here in this image, I've cut down our tables to a smaller amount, just to have them fit on the slide. If you would like to get the full view of the benchmarks, I can refer you to take a look at the paper. But if you look at the benchmark we have reviewed and look specifically at the evidence they're using, we see that the optimal case that the model or technology can correctly detect if something is a misinformation or not using evidence. This is not often the case if you look at the benchmarks available to the community. So, for example, in the first rows, you can see multimodal data sets, which have image and text as an input, but the evidence is limited to metadata, images, and text, for example. Whereas if we look at benchmarks which use video as an input or audio, we can see that in the benchmarks we have reviewed, most of them don't include any evidence, which means if we want to develop technology based on these benchmarks, it is not possible for us to evaluate if the evidence which the model is being used is correct or not correct, for example. And yeah, and the final rows are just repetition of the first rows as well, so I won't dive into this in more detail. Okay, if we look at the modeling approaches which are applied for evidence retrieval, I've mentioned that on the one side, content-based approaches are used. What are content-based approaches? These are approaches which just use the claim and its given context, such as the image which you had, which was fabricated about the US President Trump's arrest. In such kind of setting, only the image itself would be used for the verification process. Another approach, which is based on retrieval components, we see that external knowledge sources, such as knowledge bases, search APIs, etc., have been used. And for specific kind of modalities, such as for images, a very popular approach to extract evidence is to use reverse image search. So basically what models are doing, they're using the claim image as an input and trying to search across different web sources to find further context where the same image has been used in order to use this as a proof that this image is being used out of context, for example. And now let me get to the final stage, which is about verdict prediction and justification production. Here we have mapped previous work in this direction into 3 different tasks. The first task is about manipulation, the second about out of context, and final about veracity classification. So let me get into more details about each one of these tasks. So part of verdict prediction is the classification of manipulated content. So this content can be either a misinformative claim with a manipulated content, such as the claim that the former US president has been arrested, and then a fabricated image such as the one you can see here on this slide. Or another example for a manipulation would be also a correct claim, such as about a real-world event happening. We have seen this a lot, for example, during the Russian invasion on Ukraine, that a lot of claims were being spread, which were content-wise maybe correct, but images and videos were being used from different settings, from former wars, for example, in order to use it as a context for this claim. If we look at across communities, for example, in computer vision and natural language processing, we have seen different kind of terms being used for the same problem. For example, deep fakes, cheap fakes, photography, or forgery, for example. Whereas in our work, we try to concise this and refer directly to the manipulated content and refer them to manipulated images, manipulated video, manipulated audio, as the different communities are using the same terms in a different with a different meaning in the settings. Another task which falls into this final stage is out of context detection. I've already shown an example in the previous slides, which is one of the most common and easy type of multimodal misinformation being spread, where no manipulation is being applied. So each one of the content of this kind of misinformation is correct by itself, such as the image here is not manipulated as well as the text. However, they are being combined and then communicated in a way that a misinformative information is being spread. And the final task, which falls into this category, is veracity classification, which is about the classification of the truthfulness of a given statement using multimodal evidence, such as here, a claim which is given in a textual form needs to be verified by visual information extracted from the chart. And we have seen in different communities textual but also spoken claims in the audio community being used for this problem. The final step, which we also include in this stage, is justification production, following, as I previously mentioned, the aim of not only having models or technology which work very well on the problem on the one side, but on the other side, being able to justify models' predictions and models' results in a way that they are understandable by a general audience, which is maybe non-technical. And here we have seen in previous research 3 different types of justification being used by models already. So on the one side, we have seen, this is here point 1, that misinformation is being justified by highlighting manipulated parts of a manipulated content. For example, if the face of an image has been manipulated, then models not only classify that this image is manipulated, but also highlight the concrete area where the manipulation has happened in order to give a justification for humans to understand where the problem lies. But also a second direction we've seen in a very limited fashion, though, is to provide justification in a natural language, such as here on the right side example, you can see a typical justification you find on fact-checking websites, but this is just available in a very limited fashion in the automated fact-checking community currently. And the third approach is a kind of variation of the first approach, where not the misinformation part is being highlighted, but the evidence is being highlighted by the model in a way that the human reader should be able to reason based on the highlighted evidence and the given claim and get to the justification themselves. Now I will give a few insights based on the benchmarks we introduced. So first of all, I've now talked about 3 different kind of tasks across which fall into the stage of verdict prediction, justification, production. However, if we look at what benchmarks are available to the community for doing research in these problems, they're very much limited to a few different settings. For example, the problem of out of context detection, where different kind of content is combined in a misleading way. We see that the benchmarks are limited to image and text only, and we don't see other modalities being used for such kind of problems. Whereas in the real world, we very often find videos, for example, also being used in such kind of settings. Whereas for manipulation detection, there is a strong focus in the community on image and audio, on image and video, and less, for example, on audio or combination of these different modalities. And finally, the category of veracity classification, where the model should classify the truthfulness of the statement and not detect manipulation or anything else. Here we find a more diverse set of input modalities being used in the benchmarks which are already available. As you can see here, we find a combination of text, audio, video, etc. Exactly. If we look at the different sources which are used in the benchmarks we surveyed, we find a focus on out of context and manipulation classification, where the benchmarks have been created either using social media or synthetically generated. So because, and this is especially the case, for video and audio. If you can see my mouse, yeah, exactly. For video and audio, this is specifically the case where the collection of data in order to create benchmark is more challenging. And we've seen previous approaches where models have been used to manipulate videos and audios in order to create such a benchmark instead of using real-world data. And if we look at the task of veracity classification, we find here that a very popular source are fact-checking websites, which have already claims verified on them, which are then extracted and integrated into a benchmark for the research community. Here, if we look at the outputs for how the benchmarks are created, what the outputs are, which the model is then trained on, we also find a very strong bias on 2 and 3 class output labels. For example, in out-of-context classification, it would be that the model is trained on classifying if an image is used out of context or not, or if a video is manipulated or not. Whereas for just veracity classification in the last few rows, you can see that we have more diversity in the benchmarks available, where maybe not only a claim is classified as true or false, but also a more diverse set of labels are being used in order to break down the problem, similar to how it's done in the real world. Let me now finally get to the modeling approaches used for this stage. For manipulation detection, we found throughout the survey that there is a strong focus on early approaches using CNNs and later approaches using vision transformers, which are also the models which are nowadays very commonly being used for large language models such as ChatGPT, you're probably familiar with, or more recent models that they are used and trained for manipulation detection. For out-of-context classification and veracity classification, we have seen a more diverse set of models being used, and specifically approaches where the different modalities included in the problem are being encoded by different encoding models specific to each modality. And then a model is trained to do the classification task, for example, to classify if a claim is correct or not verifiable, for example. For justification production, we see that very popular are graph neural networks. These are models which try to break down their input into multiple sub-elements and embed them such that the relationship between these elements can be encoded as well. And another very popular approach are language models, similar to language models which are used for popular chatbots nowadays, which are used for justification generation as well. Yeah, if there are any questions, otherwise I will now get to the final few slides and then we can go over to the discussion, which is about challenges and future directions. So through our survey, we highlighted 5 different directions for future work we think are important for the research community to look into. The first problem is on claim extraction from multimodal content. So if you remember previously in my talk, I've mentioned that claim extraction is very strongly focused on finding text in an image or finding text in a video and just extracting this. However, if we look at how misinformation occurs in the real world, it's often much more complex. So an image is, for example, used as part of a whole story. And in order to understand this misinformation, it's not enough to just extract this image and detect if it's manipulated. But one needs to understand the entire context and then based on that, do the follow-up steps. But this is mostly missing in the research we see until today on automated fact-checking, and think that this is an important direction to go forward in order to develop models which are not only useful in an academic setting, but also applicable to the real-world problem itself. Then what we've seen is that multimodal evidence for the evidence retrieval part is limited to a few different modalities and across a few tasks, such as here you can see, no evidence is used at all. This is related to the problem that for video and audio, it's much harder to search and find relevant information. Whereas for text, easily. It can be used to search knowledge bases, search APIs, etc. Whereas for images, there are also APIs available, which can use an image as an input and output all the related images found across the web. However, for video and audio misinformation, this is much more difficult, as no state-of-the-art approaches are available for searching with this kind of modalities as input, but are very important if you would like to address the problem of video and audio misinformation, for example. Then another problem we've seen is that most of the benchmarks we've surveyed are limited to English only or to a few different languages. However, we know that misinformation and multimodal misinformation is a global problem. And in order to address this problem in a wider setting, we need approaches and benchmarks, which include further languages as well. Then another research direction or challenge we see is that the technology is developing very fast. Just this week, for example, OpenAI published a new model, which allows us to generate videos which look very realistic, but have been completely generated by a model. However, if we look how the technology is developed to detect these kind of manipulations, they're mostly limited to a specific type of model, which was used to generate the manipulated image. So if a model, for example, was generated to detect manipulated images by a model which was developed 1 year ago, then this detection approach might not work today anymore for the recent model by OpenAI. Therefore, we need generalizable approaches for manipulation detection, not approaches which are specific to the model which was used for the manipulation. And a final challenge is, as I've mentioned previously, the need for justifications for multimodal fact-checking, as there has been quite some work on manipulation detection, etc. But if justifications are missing and the capability of justifying models' decisions, these approaches are only useful in a very limited fashion to address the real-world problem and make them useful for a real-world setting. Exactly. This brings me to the end of my presentation. And here you can see an overview of the topics we discussed. And I'm looking forward to the discussion we will be having. And you can find the paper here over the QR code if you're interested.